Hello fellow problem solvers! So today we're going to be doing a problem from the Balkan Maths Olympiad 2017, problem number 1. I suggest you try this number theory problem. It's technical. For a minimum of 30 minutes, ideally 40-ish to an hour, not more than 2.5 hours if you'd like to go along with us. Give this a go for the next 5-10 minutes. And now let's begin. So we need to find all solutions x and y to this equation. Now, first thing is, what do you notice here? I notice that this is symmetric in x and y. Now, if it's symmetric in x and y, can I do anything with that? Is there maybe some way I can factor it if it's symmetric? I don't know. That's the first thing I noticed. The second thing I notice here is that, wait a second, I can write down, and this is just like a useful fact to know, that if you know what x plus y is and xy, then you can pretty much write out most combinations of x and y. If you have this is alpha, this is beta, you can write everything in terms of alpha and beta. And so maybe that's the thing we might want to do in this problem, right? Just like write everything down in those terms. So here, what would that mean? Well, here that would mean to write this as, first we have x plus y times x squared minus xy plus y squared is equal to x squared plus 42xy plus y squared. And now there's really two things to do here. One thing we could do is say, also the second thing I notice here is, and I'm going to give you time to pause for a few minutes and see if you notice anything here. And the thing I notice is, this is not of the same degree. Like this side is roughly bigger than this side, so we'll have a finite number of solutions. Which also tells me, maybe I want to pull out the GCD at some point, see what happens there when I do that, just to make sure. But now here, the second part of the problem is, I see I can factor this into one of two ways. Actually, yeah, one of two ways. I can factor this as x plus y squared and then plus 40xy. Or I can factor it as x squared minus xy plus y squared. Right? There's two ways to factor this and have like either 43 or 40xy on the other side. Now, which one would you choose? Pause for 2 minutes and think about it. And me personally, I would first like to go with the one where I factor them as 43xy. Why? Because 43 is prime. There might be something there that we can work with in an easier fashion. So let's write this as, so x squared minus xy plus y squared plus 43xy. And now what happens when I bring this on this side? I'll get x plus y minus 1 times x squared minus xy plus y squared is 43xy. And here, I invite you to pause for the next 5 minutes and come up with some ideas. And here's the next idea for me. So what do we have? We have 43xy. Let's see. Do x and y share some factors? Maybe this is where we pull out our GCD. Let's say x is equal to dA, y is equal to d times b, where the GCD of a and b is equal to 1. And then this whole thing, like the d gets canceled out here. Like we get dA, dy, what's not. And we get d times a plus b plus 1 times a squared minus ab plus b squared is 43ab. And now we don't have the GCD messing us around here. We know a and b are relatively prime. So now a question for you is, what can we infer from this equation right here? Pause for 2 to 3 minutes and figure that out. And the answer is, well, let's look at if a prime divides a, right? Let's see what a has in common with either one of these. Let's assume it has something in common with this. What do we get from there? P divides a, and p divides a squared minus ab plus b squared. Well, p divides this, so p divides b squared, which implies p divides b, a contradiction that a and b are relatively prime. So a has nothing in common with this, and b as well, in an analogous manner. This is why it's good to keep in mind symmetry. The thing I find holds for a, I should find an analogous thing to hold for b. It's important to keep these things in mind when you're solving your problems. Now, pause for another 3 to 5 minutes, try to push the problem further, push it, and what do we get? We have that this thing then, it's going to equal either 1 or 43. Because it can't have anything in common with a and b. And we can either have that this is equal to 43ab, this is 1, or this is equal to ab, and this is 43. There's nothing, like this can't have anything in common with ab, a times b. So it can only have things in common with 43. 43 has 1 and a 43 that it can have in common with it. And so we can really just focus on now solving the equation a squared minus ab plus b squared is equal to 1. This one seems to be the easier one. And another reason why this seems incredibly simple and fast and quick is because, imagine, when you multiply this by a plus b, you'll get a cubed plus b cubed is a plus b. And it's like, come on, like, we're going to solve this. Also, into the positive integers, come on, this is not going to be very difficult. So how do we do this? Well, we can write this down as a minus b. There's many ways. You can look at a quadratic equation. Is discriminant, needs to be positive. Tons of ways to go about this. But the way I would go about it is write it as this. Now I have a positive plus a non-negative is equal to 1. We are in the integers, which means we have to have a 1 plus a 0. Then this needs to be a 0. And this needs to be a 1. And so we have a is equal to b is equal to 1. And that's a solution. ab is equal to 1, 1. And now what do we have? We need to have the other equation, d times a plus b plus 1, needs to be equal to 43 times a times b. In other words, we need to have d times 2 plus 1 needs to be equal to 43. In other words, d needs to be equal to 22. So the solution for x and y becomes 22 and 22. A sanity check, just to make sure we haven't messed anything up. 22 plus 22 is going to be, actually maybe sanity check here. This is going to be 43 times 22. Actually, wait, this is going to be 43. This is going to be x minus y squared plus xy times 22 times 22 is 43 times y. Yeah, we're good. Yeah, this is going to be xy. So we had that out of the way. And now the other case, well, that one seems a bit more perhaps difficult. Like, we can't do this like a quick constraint we just did here. This is 43. Now, how do we solve this? Well, I invite you, pause for 5-10 minutes, figure out how would you solve this? You know, bada bing, bada bam, what would you do? And for me, the thing is here, I'm looking at this as, again, a minus b squared plus ab is equal to 43. And I'm thinking maybe I want to look at it this way and see, okay, do I have anything? It's a square, 43. What I have, 43 is a prime. It's 1 modulo 3. Do I know anything about a and b if they're 1 modulo 3? They're relatively prime. What can I say? Do I want to test out? Like, there's a bunch of ideas coming to my mind. One is to test out the cases 1, 4, 9, 16, 25, and 36. There are 6 cases here. It's not great. It's not the smartest thing to do, but it's a doable. It's doable-ish, I'll say. We can say without loss of generality, a is greater than or equal to b, and here we're going to have greater than b without loss of generality. Again, can a actually be equal to b? Yeah, we can have a is equal to b, but then we have a squared is 43, so that one will fall. If now, we can just like do this casework now. A is equal to b plus 1, a is equal to b plus 4, a is equal to b plus a, a 9, a is equal to, I'm thinking now as I'm writing this down, and this is totally okay if this happens to you during your exam, like you might be writing down these cases and you might think to yourself, man, I don't want to deal with this. I want to find an easier way to go about it. And then you can stop. And this is what's important to know how to be able to do in problems is to, okay, I've gone down this route. I know I can finish this, But let me see if there's a better way to go about it. Let me try to see maybe a quadratic in A. Let's look at this as a quadratic in A. And we have the discriminant will be, okay, so it's going to be so it's going to be b squared minus 4 times what? 4 times b squared minus 43. So 4 times b squared, and then we're going to have a plus 43 times 4. So this is going to be 43 times 4 minus 3b squared. Okay, this needs to be a square. What is this number? This is going to be 132 minus 3b squared. This number is congruent. This is divisible by 3. Wait, no, I'm wrong in my calculations because 162 makes a lot more sense. Actually, it's not 162, it's 172. I've been doubly wrong in my calculations. Again, that's okay. You just catch yourself. I caught myself because I found this divisible by 3, but on the other hand, 43 was not, and neither was 4. So just like some weirdness that I caught. Okay, 172 minus 3b squared needs to be a square. What are the possibilities? So this is equal to some x squared. What do I have? I can have this, and this is actually much better for me because every single one of these gives me a quadratic to kind of think about and solve, or look at the factors that I'm going to have on the other side, right? I could have 43 minus 1, 42. I know it's the answer to life, the universe, and everything, the meaning of life, yada yada, but it has a lot of factors. 2, 3, 7, come on, I think there's a lot of combinations. I don't want to deal with that. Don't want to write down that proof. So try this out. Let's see. 169. That can work. I can just set b is equal to 1, and then I'll get a corresponding a. We don't have to worry about parity issues because, what's it called? The b on the, you'll have a minus b, or here in this case actually plus b, plus or minus the thing that we're going to have out of this fraction over 2. We don't have to worry about parity there then because b and b squared have the same parity and they cancel out. And this has the same parity as b squared, as b, which has the same parity as b. So then we look at 172 minus, I'm really thinking, is there a better way to write this down? Okay, it's now going to be minus 12. So minus this is equal to 121, which is 11 squared, or 51 is 3b squared. It's 17 is equal to b squared. And now, I pause in these moments and think, is there maybe a square, like remainder I can be looking at? Modulo 5 maybe? Like, what the reason why this is not a square by some modulo. And if I think about it, modulo 5, it might be overkilling the problem unnecessarily. We could just literally, we could just do the casework, but I'm trying to find shortcuts along the way. Because that 3b squared 5 gives either, okay, so what is actually 172 is 2 modulo 5. And we're gonna have, so 3b squared can only be 3 or 2 or 0 modulo 5. So we either need the number to be divisible by 5 or give a remainder of minus 1 when divisible by 5, the square, when divided by 5. So I'm just going to do the cases. 172 minus, actually we'll see how bored I get. So minus 100, say, can it be divisible by 5? Yeah, it's because it's 2 modulo 5. So this is going to be 72 is equal to 3b squared. Divide by 3. Oh no, now we're getting bigger numbers. That's not fun. But hey, we get b squared is equal to, divide this by 3. And actually, let me just skip ahead for you. And once I skip ahead, we see that we found b is 6, b is 7, and b is 1 as the only solutions. And I just realized, wait a second, this was x squared plus 3b squared is 172. I should have just plugged in b is 1, 2, 3, 4, 5, and got the corresponding x, because I would have had less cases. Like, thinking is optional sometimes in these competitions at a certain point. Now with this, all of these b's, let's see, let me clear this up. And we get, when we solve for corresponding a, we get this. In other words, actually this would be 6 and a 1, which makes sense, again, due to symmetry, that we would get this. Probably could have skipped the case due to symmetry somehow, but this is how we chose to do it. And that's okay. You might have chosen to do this another way. You're trying to, at a competition level, figure out a way how you can write down it most concisely and finish off the problem. Now for each of these a and b, this was all in the case of like where this is the case. This is the corresponding a and b. And then we need to have d a plus b plus 1 to be equal to, in every single one of these cases, this needs to equal a times b. And would there ever be I'm curious, would there ever be a problem in these situations? Well, let's see. I'm going to have a 1 plus a 7, for example, times d plus 1 is equal 7 times 1. Yeah, this is just not going to be true at all. Interesting. What about if we have d times a plus b plus 1? So if instead we had 6 and a 7, d times 6 plus 7, which is 13, plus 1, needs to be equal to a times b, 42. So 13d plus 1 is 42. This is just not going to happen. And it seems like there are no solutions. And here's where I invite you to pause for 5-10 minutes and check your work. Now let me clear everything up, write it down nicely step by step for your viewing. And when we actually write this all down nicely, we get from here a solution. And from here we notice that we actually made a mistake. Instead of a minus 1 dA times dA plus dB minus 1, we wrote a plus 1. Again, there wasn't a solution. But then double checking, we found a solution. And then from here, we can say that the only solutions are 22, 22, and the other one being 7 and 1. And this finishes up the problem. This was, of course, one way of solving the problem. And it's worth to check out whether this whole x times y and x plus y thing would have worked. So let's just do that quite quickly. This is beta. Then I know this is x plus y times x plus, I'm going to do x plus y squared minus 3xy. That's what we have on this side, is equal to x plus y squared plus 40xy. So we have alpha cubed minus 3 alpha beta is alpha squared plus 40 beta. Now is there a way to factor this nicely? Alpha minus alpha, beta minus, if I take a beta out, I'll get 3 alpha. I don't see anything nice here. And from here, maybe I can look at this as a cubic in A, maybe not. So, or maybe I can just like say what B is in terms of alpha. I'll have alpha squared minus alpha cubed is equal to beta times 40 plus 3 alpha. And I have 40 plus 3 alpha divides alpha cubed minus alpha squared. Maybe this is cool. Now what happens when we actually bring it down to its lowest terms? How do I get 40 plus 3 alpha? This divides, I'll need to have 3 alpha cubed minus 3 alpha squared. This also divides, which is horrendous, 40 alpha squared plus 3 alpha cubed. Subtract, and we get that, what's it called? 40 plus 3 alpha divides, kaboom, minus this, which is not bad, 43 alpha squared, 43 alpha squared. Well, we've only just begun. Can I do casework? No, I cannot really do casework yet. So then I have 40 plus 3 alpha also divides, I can't deal with 43 alpha, I need to multiply by 3. So I get this actually divides 143 times 3 is equal to 132 alpha squared. Then this divides 40 times 43 alpha plus 132 alpha squared. Subtract this from this, 4t plus 3 alpha then divides 40 times 43 alpha. I need to do it times 3. And then I'll have 40 plus 3 alpha divides, when I subtract the corresponding thing, 40, what do I need to have? I'll need to multiply, so I'll need to multiply the 3 alpha by 40 times 33. So I'll have 40 squared plus 33. Now the trouble here is, well, we can do this. We can think about trying to solve this and worry later that the alphas and the betas corresponds, though what you can see here is that this is going to have a hell lot of factors. And that's the problem, because 40 is big. 40 is big. Though maybe how many, even if we just look at factors that are bigger than 40, which is what we need to look at here, it is still a lot of numbers. And actually, to be perfectly honest with you, I think I might have messed up somewhere. Because now 7 and 1, or 7 times 1, actually 7 and 1 is, or is it a solution? Does 50 squared divides. I for a second thought I've missed a solution, but it doesn't seem like I have. Actually, no, 7 times 1, 21, 61. 61 doesn't divide this. So, goes to show, like, if you're doing this heavy algebra stuff, be careful with your algebra. I was not. And now I have to go all over. And in a competition, I wouldn't know. So, this goes to show, like, you can try, you know these techniques, but don't be too tied up in them. And if you see like you're coming to a point where you're going to have a lot of factors, I made a mistake somewhere. But if you're going to have a lot of factors, try to find another thing. Unless it's potentially an early competition where they want you to like actually show that you can do a lot of casework, in which case, sorry. But usually at this level of a competition, this is not the thing. There might be some casework, but this is totally fair game. This finishes up this nice little technical problem, and as always, thanks for problem solving.